All right, so I'm on that white half sheet. We're going to do these examples first. So it should be the one after your vocab. All right, so okay. So these are just a couple of problems that are pretty basic that go along with kind of what we did yesterday. So I want to do those first, just so you guys, if you see problems like this, you know what to do. Okay. So first off, we're going to write an equation of a circle with a center of 3, -4, but it passes through this point. So in other words, what am I missing? The radius. So this is similar to the ones that we did on Monday, where we just kind of have to imagine where the points would be. So if I look at a graph, all right, 6, 2 would be about right here. 3, -4 would be about right here. All right, it's not going to be exact, but if this is the center of my circle and this is the edge, all right, what do you think I'm going to do? So how do you think I'm going to find what that radius is? Do rise over run in order to create a what? A right triangle. All right. So, in other words, I want to create a right triangle so that I can do what to find the radius? What theorem helps us solve right triangle? Pythagorean theorem. So a squared plus b squared equals c squared. So, remember, to find the distance vertically and horizontally, what do we do? So for vertical distance, how do you find it? Or vertical distance. So the vertical is at your x or y values. Your y values. So you subtract your y values. I'm going to do 2 minus -4. So that'll give me what? 6. So that's my distance there. What about for my horizontal side? How do I find it? With the x value. So you subtract the x value. So 6 minus 3. So this would be 3. So these are the two values I'm going to put into the quadratic formula in order to find my radius, r. So your radius is going to be represented by which part of the Pythagorean theorem? C squared. So if I put in the Pythagorean theorem, this would be 6 squared plus 3 squared is equal to r squared. So all I did was take the two sides that I found and then put them into the Pythagorean theorem. And you could leave c squared if you want. I just want to put r squared so you know that it's the radius. So what's 6 squared? 36. What's 3 squared? 9 is equal to r squared. So this would be, what's 36 plus 9? 45 is equal to r squared. What's my last step to get r? Square root both sides. That goes away. R is equal to, we'll just leave it as the square root of 45. Now, I need to put in, oops. Oh, it doesn't matter. It still creates the same triangle. Okay, so my circle will just be moved. It's over here. Triangle's still the same, so the work's still the same. But the circle is just in the wrong spot. That's an ugly circle. That's like a very jacked up circle. It cannot even call itself a circle. But, all right. So now that we got our R, we can put it into our standard form formula. So remember, that's x minus h squared plus y minus k squared is equal to r squared, where HK is the center and R is the radius. So given my center, which is 3, -4, how would I write the left side of my equation? So x minus 3 squared. Someone else tell me what the y's would be. How would I write the y portion using the center? So we're using this point. Y plus 4. Good. All squared. It's equal to the square root of 45. But what do I have to do to it? Square it. Because this is just r. I want r squared. So if I clean it up, this will be x minus 3 squared plus y plus 4 squared is equal to, what's the square root of 45 squared? Just 45, because the square root and the square cancel each other out. Another trick is that if you look right here, we technically already have what r squared is as well. So if it didn't ask you to flat out find the radius, you could have just stopped there at r squared equals 45 and then plugged that back in for r squared without having to take the square root. But if you like having to do the square part so that you get into the habit of doing that, that's fine as well. I don't care. All right. So that's the first one. And that one, we've kind of already done some problems like it before in your packet. So that one you should be semi-familiar with. All right, let's look at the next problem. So the diameter of a circle has endpoints of -3, 0, and 4, 6. And wants us to find the equation of the circle. All right. Now, what does it mean by diameter?
Is the entire like all the way through? I think it's half. No, it's like radius is half. Diameter is the whole. Yeah.
So diameter is a segment that goes from end of the circle to end of the circle and it cuts through the center. So if I was to kind of give an estimate, this would be -3, 0, and this would be 4, 6. So about right here. So our circle would look something like this. Again, that's a terrible circle, but y'all get the point. There we go. So this is our diameter. And they want us to find the equation of a circle. So let's think about this logically. If the diameter, remember, this graph is not drawn to scale, but our center will probably be about right here. But that doesn't guarantee, it looks like it's on the y-axis, but it doesn't guarantee that it's on the y-axis because we don't know. All right, I didn't draw this graph to scale. Okay, so we can't assume. So, how do you think I would maybe find the center?
Cutting it in half now?
But we don't know what the length of the diameter is. You could, but we don't know what the center is. How do I find the center? It's the center, but we don't know what it is. So this is what we don't know. So we know that this is -3, 0. This is 4, 6. And we don't know what this is yet. Nope.
But didn't that would create a triangle though? I can't.
Because we don't know what the rise over run would have to be. So let's think about this logically, guys. The diameter can be split apart into two what? Radiuses or radii. All right. So in other words, if it's broken up into two congruent pieces, because all radiuses are the same in one circle, what does that make the center? The midpoint. Do we not know how to find the midpoint using 2 points? Or you should.
Well, all of that.
Okay, so all right, so in other guys, so in other words, we use the midpoint formula. And all the midpoint formula is, and I would write this down, is that you're basically taking the average of the two x's. So x1 plus x2 over 2, and you're taking the average of the two y's. So y1 plus y2 over 2. Oh yeah, this is a math 1 concept. It is definitely a math 1 concept. How do I know? I taught math 1 last year.
I haven't learned anything in math 2.
You should have learned it in math 1, so. All right, so first things first, we're going to find the midpoint, because once we find the center, we can find the radius. All right. So using the midpoint formula, I'm just going to do the x's, add them to each other and divide them by 2. Same thing with the y's. Add the two y's together, divide it by 2. So -3 plus 4 is 1. Divided by 2 is just 1/2. And 0 plus 6 is 6 over 2. So if I simplify this further, my center would be at the point 1/2, 3. So that's equal to my center. So this center point, and again, it's not drawn to scale, is 1/2, 3. Now, we can then find our distance. All right. I would recommend using the easiest pieces possible. Okay, so I would recommend when we draw our triangle to use this one. So use the one where there's a 0 in your number, because when you're subtracting 0, it's very easy to do. So, first off, if we do our horizontal, what two values are we subtracting? So we're doing our horizontal with the center and one of the points. It doesn't matter which one. But we got to use the center point. So we could use 1/2 and -3. So we can do 1/2 minus -3. So we're just adding 1/2 and 3. So that is just 3.5. Or we can just say, if we do a quick conversion, that would be 7/2. All right. Now, this one over here, we have 3 minus 0. So that's just 3. And then we're finding r. So we're going to put these numbers into our Pythagorean theorem. So this would be 3 squared plus 7/2 squared is equal to r squared. So this would be 9 plus, if you square a fraction, it's the exact same thing as squaring the top number and squaring the bottom number. No, you just leave it as the top number squared over the bottom number squared. So it'd be 49 over 4. It's equal to r squared. So if I flip the fraction, you could put this in your calculator, but I'm just going to do it by hand. But if you change the fraction to common denominators, 9 as a terms of fourth, you just think of whatever 9 times 4 is, so that's 36. The 36 over 4 plus 49 over 4 is equal to r squared. So 36 plus 49, that would be 65 over 4 is equal to r squared. And I'll be perfectly honest, we're going to stop here for r squared. We're not going to take the square root or anything. We're just going to leave it like that. You could if you want to, but you'd end up having to square it back anyway for the equation. Oh, it's 85, not 65. My bad. All right, so here's my r squared, and here is my center, which is what I need for my formula for the equation. So what would my equation of the circle be? So it'd be x what? Minus 1/2 all squared plus what? Y minus 3 all squared, and it's equal to 85 over 4. I don't know why I put 84. All right. So again, since we found r squared and not just r, we can just put straight up 85 over 4. You can stop here at r squared if you want. If you wanted to find r, you could square root both of these. And it'd be 85, square root of 85 over 4 is equal to r. Well, you just have to square it anyway. So it's counterintuitive. All right. So the last thing we're going to do is we're talking about if it's tangent to the x-axis, tangent to the y-axis. Okay. So what does tangent mean? Tangent means that it hits at one point. All right. So it hits at one point on the y-axis, and then it hits at one point on the x-axis. So that's what tangent means. It means it hits at one point. So it's a line that hits the circle at one point. So in other words, those lines are our x-axis and our y-axis. Now, it didn't specify which point, so we're just going to make one up. So I'm going to say for this one, it's tangent to the x-axis at the point 1, 0, and it's tangent to the y-axis at the point 0, 1. Easy numbers. All right. So I'm going to draw my circle where it's tangent to the x-axis. So if I'm saying it's tangent at 0, 1, so right here, and my center is at 5, -3, so like about here. My circle would look something like this. Oh my god, it's a bad circle. All right. I told you it's ugly. All right. So I'll put the center here so it looks a little better. Wait, why am I trying to? Okay, there we go. But good enough. Okay, you know what? Hush. Okay, so I'm not an artiste. Okay, so this is at the point 1, 0. Guys, stop talking. And this is at the point 5, -3. So now we just need to find our radius. All right, so we're just going to do rise over run again. All right. So if I'm talking horizontal distance, what am I subtracting? So horizontal means what values, x's or y's? X's. So I'm going to subtract the 5 minus the 1, so it's 4. What about the vertical? The y, so I'll do 0 minus -3, so that is 3. And we're trying to find r, which is here. So I'm going to do 4 squared plus 3 squared is equal to r squared. So that means that this would be 16 plus 9 is equal to r squared. So 25 is equal to r squared. So what's the radius equal to? 5. So if I put this in the equation of a circle, so our center is this point. What's the equation if it's tangent to the x-axis? So what's my center? 5, negative 3. So how would I write that in the equation? X minus 5 squared plus y plus 3 squared, and it's equal to, what's r squared? 25. So that is our, if it's tangent to the y-axis. I mean, not the y-axis, the x-axis. Yes. Oh, that goes along with the previous problem, so I just marked it off.
It's like it starts with like 0 and then it's something and then 3.
Oh, 0 minus negative 3. Yeah. So I just did minus negative 3, but then I circled these to show that you add them. All right, last one. Shh. So I'm going to draw my graph as somewhat best as I can. So if I want tangent to the y-axis, it's going to hit at this point right here at 1, 0, or 0, 1. So I'm going to draw the circle semi-okay. And then my center would be like here. Good enough. Oh, wait, no, the center's in the wrong spot. The center would be like here. Oh, God.
I'm just playing with you.
Okay, good enough. Okay, so see, this is why I don't like doing circles. I always screw it up. Okay, so shh. This is the point 0, 1. This is still the same center point, so 5, negative 3. So we're going to do the same thing to find our radius. We're just going to do wrap. We're just going to do our rise over run. So for our horizontal, what are we subtracting? 5 minus 0. So that'll give us 5. Because remember, you always want to do biggest minus smallest. What about up here, the vertical? We do 1 minus negative 3. So that would equal 4. We're trying to find R. So, boys, stop talking. So this would be 4 squared plus 5 squared is equal to R squared. So this would be 16 plus 5 squared, 25 is equal to R squared. So 41 is equal to R squared. Square root both sides. The square root of 41 is equal to R. So what would my equation be? So the center is still 5, negative 3. So in reality, the first part of our equation is the same as our previous one. So it'd be x minus 5 squared plus y minus or plus 3 squared. And it'd be equal to what? 41, which is r squared. So guys, pretty much almost all of these, it's the exact same method. You just had to do like, the only one where you had to do like one extra step was this one, the diameter one. Everything else was pretty much just make a right triangle, find the vertical and horizontal heights, do the Pythagorean theorem. All right, so we're going to go ahead and take our 3-minute break. And when we come back, we're going to do those other 2 journal entries.
I'm tired of riding.
He studied that video. Alright.
Guys, your other class is in session. Be respectful.
I just can't. Later. I already got paid on community. Oh, I got paid. Oh, yeah.
So guys, if you're in here during the break, for the next part, I recommend you get like at least 6 different colors.
Like
No, like color pencils. Because we'll be doing some
Yeah,
labeling
we're
and
not
everything. So if you have like different colored pens, or if you need color pencils, they're on the shelf. Just get like 6 different colors.
Yeah, choose. You gotta choose 6 or 7 different colors.
There's 6 or 7 on the floor right now.
Yeah, 6 or 7.
I have 3. And I did white.
White?
White gray.
Very good to use those.
Maybe neon beige. Neon beige.
Neon beige. Can I get sage?
Sage brush. Is that too good?
Oh no.
I heard that. First time? Yeah. Oh, light brush. What?
Open going. Open going.
Alright guys, so like I said, you need at least 6 different colored pencils or colored pens because we're going to be doing a lot of labeling. So having those different colors will really help. They just flat tired me.
Sorry.
So once you get your colors, go to that next foldable in your journal. 6. Color pencils, color pens.
I think you have 3 of the things, or 2 of the things. I'm trying to look for it, but I'm leaving at 10:30.
That's fine. Yeah, that's fine.
Yeah, me too.
Bull and bull. All right, so I mean, I can't tell you to do that or not. You have to go. Yeah, you got to go to the office and ask me. All right, so all right, so we're on that next foldable in your journal. So the one that says Circle Basics. So before we get into all the different properties of circles, we first need to go over some basic vocabulary. All right. So we're going to go over what each part of a circle is that you'll see and how you name them. All right, because how you name them is very important. It's like when we were doing the quadrilaterals, how we named angles versus sides was a very big difference. So, first things first is just the definition of a circle. So, a circle is a set of all points from a fixed distance and that fixed distance is the radius from a point. And that point is the center. So when we name a circle, we name it based off of whatever letter is on the center point. All right. So I don't think there is a letter on the center point. Oh, yeah, it's J. Okay. So if we look here, our center is at point J. So this is our center. So we would name our circle as you draw a little circle with a dot in it. And you write a J next to it. That's how you name the circle. So just like how if you're naming a triangle, you put the little triangle in front of it. With circles, you draw a little circle, but you put a dot in it so that they don't mistake it for a 0 or an O or whatever. So this right here is my circle. And obviously, like, y'all should at least recognize what a circle looks like. That's kind of, kindergarten. Now, the next thing that we need to know what it is a chord. So I would use a different color for this one. So a chord is a segment that has endpoints on the circle. So in other words, it's a line or a line segment that has both endpoints on the circle, not in the circle, on the circle. All right. So for example, if we look at A to D, this right here is a chord. So notice how I didn't highlight the line part of it. That's because if it goes outside the circle, it's not a chord. The chord is a line segment. So we would name it as segment AC, just like we would if it was a quadrilateral. Now, another chord would be right here. Technically, the diameter of a circle is a chord because it goes from two endpoints on one end of the circle to the other. So this is also a chord. And we would name that DG with a line over the top. Now, the next thing we're going to talk about is what's called a tangent. All right, so I kind of already mentioned this in our last journal entry, but a tangent line is a line, so it's not a line segment, it's a line that intersects a circle at one point. So it actually doesn't go through the circle. A tangent line physically does not go through a circle. It literally just hits it, like it just gives it like a little peck and then moves on its way. All right. So it's just barely touching the circle. So if we look right here, line XM, so this line right here, see how this point is just touching the circle, but the line itself is actually not anywhere in the circle at all. It's just briefly touching it and then going on its merry way. This line right here is the tangent line. So this is our tangent line. And how we name it, so a line, similar to a line segment, you name it with 2 letters, so XM, but the symbol over the top, you would have to put 2 arrows on either side to represent that it's a line, not a line segment. So those arrows on the sides mean that it's a line. If it doesn't have arrows, it's a line segment. Now, I'm going to scoot over to secant so that if you didn't finish getting the definition of tangent, it's still there for you. So a secant, it's also a line. So just like a tangent line, it's also a line. But the difference between a tangent line and a secant line is that it intersects a circle at 2 points. So instead of just touching the circle, it actually goes through the circle. So my secant line here is line AC. So from here all the way to here, that line is my secant line, because if you notice, it intersects the circle at 2 points, and those points are, and those 2 points are A and C. All right. But since it has those arrows on the end, we know it's a line, so it goes on forever. So that's a secant line. And we name it just like we name a tangent line. So you use 2 points, so AC, and then you draw the little line symbol over it. You guys see why I wanted you guys to have colors now? Yeah. All right. Now, a radius. So you guys should know what a radius is, but if you want a formal definition, it's a segment from the center of the circle to a point on a circle. And also, just to note, the length of the segment is half the diameter. So remember, a radius is half the diameter, which you guys should already have been familiar with. So my radius, the most obvious one is right here. So from F to J, it goes from the center of the circle to a point on the circle. Now, the radius is not considered a chord because its center point is not on the circle. It's in the circle, but it's not on the circle. So this is a radius. Another radius would be from G to J as well. So right here would be a radius. And yeah, D to J. That would also be a radius. And to name them, we just name them like line segments. So JF, JD, and JG. And they have just the straight line over top, not a line with arrows, because they're line segments. They have endpoints. And then finally, the last word that we're going to talk about is diameter. So let's see, what color have I not used yet? Let's use dark purple. All right, so the diameter. It is the longest chord of a circle. So like I said, the diameter is a chord. It's also considered the longest chord of the circle because it goes from the widest part of the circle to the widest part of the circle. It physically cuts the circle in half. And it goes through the center. So the only way that it's the diameter is if it goes through the center point. If it doesn't go through the center point, it's not the diameter, it's just a chord. And remember, so if the radius is half the diameter, that means the diameter is what? Double the radius. So remember, the diameter is also double the radius. So my diameter would be from G all the way to D. So this would be my diameter. And we name it just like a line segment. So it'd be line DG. So this is just basic vocabulary because you need to know this because we're going to be throwing around these words a lot in this unit. All right, so I'm giving you this now so that you know what I'm talking about. All right, we all good? Speak now, forever hold your peace. I'm moving on. Okay. So guys, if you are done, the next section we're doing is that next foldable. And you're still going to want your colors. Good? All right, is everyone good with the circle basics? Do I need to leave it up any longer? All right. So we're going to go to the arcs foldable. So that last foldable that you guys should have. No. This one, just keep all 6 out because we'll probably switch off a little bit. All right, the last little bit of vocab that we need to know about is in terms of arcs and a couple of basic angles. All right. Now, first thing we're going to talk about when we talk about, before we even get into arcs, we first need to understand what a central angle means. Now, when you hear the word central, what do you think of? Center. All right, so if you believe it's an angle formed, so it's an angle formed by 2 radii. Remember, radii is plural for radius at the center. So in other words, the vertex of the angle. So in other words, the vertex of the angle is at the center. So, for example, angle ACE is a central angle. Angle DCF is a central angle. So this is a central angle. This is a central angle. This is a central angle. And this is a central angle. So all of these are central angles. And let me write what's inside. Now, we name them just like we name angles in quadrilaterals or triangles. You would use the little angle symbol, and then you use 3 letters where the vertex is the middle letter. So this would be ACE, angle ECF, angle FCD, and angle ACD. So all 4 of those angles that I marked, those are their angle names. And notice the common denominator here is the middle letter is the center. So whenever you name an angle, because some of you guys were having trouble with this when you were doing your proofs, the vertex is always the middle letter, always. Besides that, it doesn't matter whether you put the other 2 on either side, but the middle letter always got to be the vertex of the angle. Now, that's a central angle. Now, something to note when it comes to a central angle. So, something to note, go ahead, is that the measure of a central angle is congruent to the measure of what we call its intercepted arc. Boy, stop talking. Now, basically, the intercepted, yeah. So the intercepted arc, oh my God, I can't talk today. Intercepted arc, all right? I like to think of it like the ice cream on the ice cream cone, all right? Because the angle itself is the cone. The arc is the ice cream on top of the cone. So this arc right here would be your intercepted arc. So over here, the angle is FCD. So the intercepted arc is right here. And whatever that angle measure is for the arc, or whatever the angle measure, oh my God. Whatever the measure of the arc is, that's the same measure of the central angle. So if this arc is 45 degrees, what is this angle? 45 degrees. If this arc is 60 degrees, what is this angle? 60 degrees. And it works in vice versa. So they gave you the angle and they want you to find that arc. It'd be the same thing. Now, we then have what is called a minor arc. So there are 2 main types of arcs. It's minor arcs and major arcs. So a minor arc is a portion of the circle. Stop talking. It's of the circumference, so the perimeter of the circle, of a circle that measures less than, so emphasis on less than, 180 degrees. Now, if I'm talking 180 degrees of a circle, how much of the circle is that? Half of it, because a circle adds up to 360. So it's less than half the circle. Now, when we name a minor arc, we name it using 2 points. So similar to a line, you name it using 2 points. All right. So if I went back up here, an example of a minor arc would be either you could use your intercepted arcs that we just wrote, or just so we have some differentiation here, AD is also considered a minor arc. So technically, these two intercepted arcs, the green ones, are also considered minor arcs because they're less than 180 degrees. But we name that arc AC, and we put a little kind of arch symbol over it. So the arc symbol, literally, it looks like you're drawing like a little parabola over the top of it. So math people, again, we like to the point. So a lot of our symbols that we use will basically describe what it looks like. If it looks like an arc, it's describing an arc. Another thing to note about a minor arc is that it is the shorter path between those 2 points. Because on the opposite end of things, we have a major arc, which a major arc, if you can guess what it is, it's a portion of the circumference that measures more than 180 degrees. So minor is less than 180, major is more than 180. Now, biggest difference between a minor arc and a major arc when we name them. A major arc uses 3 points. So you almost name it like you would an angle. So you have to use 3 points to name a major arc. And 2 of those points have to include the endpoints. And then the third point, it's just another point that it passes through. So, for example, if I go back up to my circle, so still using AC. So the shorter distance from A to C is our minor arc. But if you look, there's another arc that can be formed between A and C. This arc right here, if we go all the way around the other end of the circle, where there's no blue, that right there is our major arc, because if you eyeball it, it definitely looks greater than 180 degrees. Now, there's a couple of different ways you can name it. So, one way you can name that specific arc is arc AED. So it starts with A, it goes through E, ends at D. Another way is ABD and AFD. So what's special about these is that they're the exact same arc. So this is the exact same arc. We just named it in different ways. So as long as the endpoints are on either end, that middle letter doesn't really matter, as long as it's a point that's between those two letters on that bigger arc. Because if you notice here, E, B, and F are all between A and D on the circle. So you can use any of those points to represent the major arc. It doesn't matter which. And remember, with a major arc, it's the longer path between 2 points. Now, our last definition is one that you guys should be fairly familiar with. And that would be a semicircle. Now, when you hear the word semicircle, what do you think? Half a circle, and that's exactly what it is. It's an arc that measures exactly 180 degrees. So a semicircle is an arc that measures 180 degrees. So in other words, it's half the circle. And another thing to know about the semicircle is that it's made from the diameter. So either arc formed on either side of the diameter is considered a semicircle. So an example of that would be over here. Like if I draw a line from ED is my diameter, so if I draw the arc from E to D, this would be a semicircle. E to D, or whichever way, it doesn't matter. The other side of D to E is also a semicircle. Now, with a semicircle, just like a major arc, you name it using 3 points. So a minor arc is the only arc that you use 2 points for. All the others you use 3. So, for example, this could be arc EAD. That's the one that I marked. And then let's say I wanted to mark the other side. So the other side semicircle, that could be either arc EBD or arc EFD. So these two are the same semicircle. EAD is the other side. Now, why do we go through all this stuff? Well, now we can find some angle and arc measures based off of that information. All right. So I'll give you guys a second to finish writing. All right. So now let's answer these questions here. So not only are we going to find the measures of the angles and arcs in question, we're also going to label what they are. So whether they're a minor arc, major arc, central angle, whatever. All right. So given circle C, we're going to find the measure of each arc or angle that is named. And next to the measure, we're going to write the name of the arc or angle. And just to note, ED is the diameter. So some of these we already found. So for example, FCD, which is right here, we found that to be what? 60. Found to be 60. And what is FCD considered? It's a central angle. And guys, you can know if it's going to be an angle or an arc based off of the symbol. You see this little angle symbol, it's going to be an angle. So angle is going to be in its name. If you see the arc symbol, arc's going to be in its name. All right. What about AE? So arc AE. So right here. Intercepted. Yeah. Yeah, it's the intercepted arc that we found, and it's already labeled as what? 45 degrees. Now, we know it's the intercepted arc of that central angle, but what's its other name? So what type of arc is it? It's a minor arc. Why? It's less than 180 degrees. Now, it then asks for arc ADF. So ADF is right here. Now, if it's an arc labeled with 3 letters, we can assume it's either going to be a what? A major arc or a semicircle. Now, to find the angle measure, all right, we need to find whatever the arc measure of AD is. How do you think I'm going to do that? So I need to find AD first. How would I do that so I can find the entire measure of this arc? Yes. Right. So if you notice, AD is part of the semicircle EAD. And we already got a piece of that semicircle to be 45. So if I subtract 180 from 45 degrees, that'll give me 135 degrees, which is the measure of this minor arc. Then, how would I find the measure of ADF? You just add them together. So you would do 135 plus 60. So that'll be 195 degrees. So this big arc right here is 195 degrees. And we already said it's a major arc because it's bigger than 180. And guess what? The next question is that minor arc that we just found, which was what? 135. So that's the minor arc that we literally just found. Now, angle ACD. So it's this angle with the 3 lines right here. What would the measure be? 135. Why? It's intercepted arc is AD, and we know that arc measure is 135. So this would be 135 degrees. And what type of angle is it? It's a central angle. Now, what about angle ACF? So this big angle right here. How do you think I would find that? Well, you're trying to find ECF, which you could do, but there's actually an easier way given the information we already know. Nope. So guys, we know that this arc right here, so ADF, that arc is 195. All right, when we're talking about angles, we're typically talking about they have to be less than 180 degrees. All right. So this big angle that I marked right here, if I know that this side is 195, how do you think I would find this side? Take it away from 360. So I would do 360 minus 195, which would equal what? You guys got a calculator, right?
You said 360 minus 45?
195.
195?
Mhm.
I'm gonna guess and go 35.
So it's 165. And it's a central angle. So this angle right here is 165 degrees.
Can you zoom it up a little? Like with the equals and stuff.
All right, then we have AFD. So arc AFD. So this big arc right here. So the one that I marked as the original major arc. It's not 180. It's not 195. It's 180 plus 45. So if you look, this big purple arc right here, this is the one we're trying to find. We know it's, boys, stop talking. So we know that it's part of a semicircle plus that 45-degree arc right here. So we just need to add 180 to 1. So we had to add 180 and 45. So that would give us 225. Is that going to be a major or minor arc? Major. Last one, FDE. So F, D, and E. So what do you think you would find for this arc? So this big arc right here. 180 plus 60. Because it's a semicircle plus this 60-degree piece. So that would be 240 degrees. And it's still a major arc. All right, so we're going to call it quits for today. So your homework for tonight is a delta math. All right, you guys got about 10 minutes until class ends, so I expect you to at least work a little bit on something. Like, this is not pack up time. This is work on something time.
Can I go to the office?
Yes, let me write you a note, though. Make sure my color pencils go back in the bucket.